Bismillahirrahmanirrahim. Gas. The particles move rapidly and collide constantly. Here particles occupy a small part of the total volume. Little mutual attractions or repulsion between particles. Collision cause changes in direction and velocity. Gas model. Gases are composed of teeny widely spaced particles. For a typical gas, the average distance between the particles is about 10 times their diameter. Gas model. Because of large distance between the particles, the volume occupied by the particles themselves is negligible. For a typical gas at room temperature and pressure, the gas particles themselves occupy about 0.1% of the total volume. The other 99.9% of the total volume is empty space. This is very difficult than for a liquid, for which about 70% of the volume is occupied by the particles. The particles have rapid and continuous motions. For example, the average velocity of a helium atom at room temperature is over 1000 meter per second. The average velocity of the more massive nitrogen molecules N2 at room temperature is about 750 meter per second. 500 meter per second. Increased temperature, increased average velocity of the particles. Particles are constantly colliding with the walls of the container and with each other. Because of these collisions, the gas particles are constantly changing their direction or motion and their velocity in a typical situation. Gas properties and their units. Now I tell you about the ideal gas. The particles are assumed to be point masses, that is, particles that have a mass but occupy no volume. There are no attractive or repulsive forces between the particles or gas molecules. Gas properties and their units. Pressure, force acting per unit area is known as pressure. 1 atm atmosphere is its unit. Bar also its unit. 101 atm is equal to 101.325 kilopascal. 760 mm it's also equal to 760 torr. 1 bar 100 kilopascal, 0.9869 atm. Volume. The units of temperature is in Kelvin. Number of gas particles in N. For each of the following pairs of the properties, 1 describe the relationship between them, 2 describe simple system that could be used to demonstrate the relationship, and third, 1 show explain the reason for the relationship. V and P when N and T are constant. P and T when N and P constant. V and T when N and P constant. There are 4 parameters of gas: volume, pressure, number of moles, and temperature. 2 will be varied and other 2 will be remain constant. Apparatus for demonstrating relationships between properties of gases. Decrease the volume, increase the pressure. When decreased volume, increased number of gas particles and volume of container also increased. Increased number of particles close to any area of the wall. Increased number of collisions per second, area of wall also increased. Increased force due to collisions, area of the wall, increased gas pressure. Boyles law. The pressure of an ideal gas is inversely proportional to the volume it occupies if the molecules of a gas and temperature are constant. Period inversely proportional 1 over V to V and T are constant. Decreased volume, increased pressure, increased volume, decreased pressure. Increased temperature leads to increased pressure. P direct proportional to T, N and V are constant. Galas's law. The pressure of an ideal gas is directly proportional to the Kelvin temperature of the gas if the volume and moles of gas are constant. P direct proportional to T if N and V are constant. Increased temperature, increased pressure, decreased temperature, decreased pressure. Charles' law. Volume occupied any gas of a gas is directly proportional to the absolute temperature T if N and P, number of moles and pressure are constant. Increased temperature, increased volume, decreased temperature, decreased volume. Increased mole of gas leads to increased pressure. P directly proportional to the number of moles if T and V are constant. Relation between N and P: increased number of gas particles, increased number of collisions with the walls, increased total force of the collisions, and increased gas pressure. Relationship between moles of gas and pressure. If the temperature and volume of an ideal gas are held constant, the moles of the gas in container and the gas pressure are directly proportional. Increased moles leads to increased volume. Avogadro's law: for ideal gas, the volume and molecules of gas are directly proportional if the temperature and pressure are constant. Ideal gas equations: P directly proportional to N if T and V are constant, P directly proportional to T if N and V are constant, P inversely proportional to